Welcome to solverfy.
Here in this question, because the lens is converging, so its focal length will be positive and there will be a possibility of both real and virtual images. So now we consider here that if f is the focal length of the lens, then for a particular object distance p and image distance q, the lens equation can be written as 1 divided by f equal to 1 divided by p plus 1 divided by q. Now we consider this as equation 1. Now comes to part A. So here we have given the distance between bowl and candle is d equal to 1.50 meter. Now here if P1 and Q1 are the object and image distance, and since real image is forming on the bowl, then P1 plus Q1 is equal to D. Now, using equation 1, we get 1 divided by F equal to 1 divided by P1 plus 1 divided by Q1. Now, we can write this as 1 divided by F equal to 1 divided by P1 plus 1 divided by D minus P1. Now here we substitute 1.50 meter for D. Therefore we get 1 divided by F equal to 1 divided by P1 plus 1 divided by 1.50 minus P1. Now on simplifying and rewrite this for F, we get F equals to 1.50 P1 minus P1 square divided by 1.50. Now comes to part B. Now here the distance through which the lens moved is given as x equal to 90 centimeter, or we can write this as 0.9 meter. Now here we consider that if P2 and Q2 are the object and image distances in the final situation, then the final object distance can be written as P2 equals to P1 plus x, or we can write this P2 equal to P1 plus 0.9 meter. Now similarly, final image distance will be Q2 equals to Q1 minus x. Now we can write this as Q2 equals to 1.50 minus P1 minus 0.9. So we get Q2 equals to 0.6 minus P1. Now using equation 1, we get 1 divided by F equal to 1 divided by P2 plus 1 divided by Q2. Now here, on putting the values of P2 and Q2, we get 1 divided by F equal to 1 divided by 0.9 plus P1 plus 1 divided by 0.6 minus P1. So now on simplifying this, and let's rewrite this for F, we get F equals to 0.54 minus 0.3 P1 minus P1 square divided by 1.50. Now comes to part C. So here from above cases, object distance in the initial situation can be calculated as 1.50 P1 minus P1 square divided by 1.50 equals to 0.54 minus 0.3 P1 minus P1 square divided by 1.50. So from above, we get 1.8 P1 equals to 0.54. So P1 equals to 0.3 meter. Now comes to part D. So here, now we using the focal length relation in part A, we can calculate the focal length. Therefore, we have F equal to 1.50 P1 minus P1 square divided by 1.50. So now we can write this as F equal to 1.50 multiplied by 0.3 minus 0.3 whole square divided by 1.50. So we get F is equal to 0.24 meter. Therefore, the focal length equals to 0.24 meter.